My name is Charlotte and I'm 8 years old, and today I'm talking to Professor Enzo Porrello. Hello Enzo, can you tell me what is a stem cell?
So a stem cell is a cell that can turn into different cell types in the body.
Why is stem cell research important for child health?
So stem cell research is really important for child health because here at Murdoch Children's we're really trying to address some of the biggest health challenges, and we're trying to find new treatments for currently incurable conditions, and that means we're really trying to help children whose hearts might not work properly, or their kidneys might not work properly, or their immune systems might not allow them to defend themselves against bugs.
Is it true that you're creating a special patch for the heart?
So yes, that's true. We are growing patches of heart in the lab, and this is pretty amazing because what we can do is we can grow stem cells. Again, we can grow those stem cells from your own cells in our lab, and then we can grow beating heart tissue in the laboratory, and you can actually look at that heart muscle down the microscope and see it beating away, just as in the same way as your own heart is beating in your chest right now. And we can use these heart patches to potentially improve the function of the heart in children whose hearts are not working properly.
What's the future look like for stem cell research?
So I think the future looks really exciting for stem cell research, and the reason I think that is that the things that we're doing today, we couldn't have even imagined that they were even possible only 5 or 10 years ago. But we're really fortunate to be part of a global network, so we're connected with other researchers all around the world who are helping us to do this together, and that's really exciting time to be a researcher here at Murdoch Children's Research Institute.
High five.
There we go. I think you can tell by the look on my face in that video that I was very intimidated during that interview with Charlotte. So I'm Enzo Porrello. I'm the director of the stem cell medicine theme at MCRI. And across stem cell medicine, our mission is to be at the forefront of stem cell research and translation globally. And we are doing this through our partnerships, both locally on campus with our clinicians at the Royal Children's Hospital, internationally and increasingly with our industry partners. And our vision is the development and ultimately the delivery of novel, innovative, safe and effective stem cell-based treatment options for diseases that impact children so that they can all live a healthy and fulfilled life. So across stem cell medicine, our researchers work across a range of different disease areas, from heart and kidney disease to disorders of the blood and immune system, musculoskeletal disorders, neurodevelopmental disorders. You heard about some of the work that we're doing in respiratory disorders that intersect with infectious diseases. And also we have a large and growing activity in cancer. And this stem cell medicine research program centers on a technology known as induced pluripotent stem cells. And this was introduced earlier today during Rhiannon's talk. And essentially what this technology allows us to do is it allows us to take a cell from any individual. We can reprogram that individual cells to this type of stem cell in the laboratory, and those stem cells have the potential to turn into all of the different cell types in the body. And at MCRI, our researchers are global leaders in this space, and we've developed many of the methods that allow us to differentiate or turn these stem cells into various human cell types. And we can then use those human cell and tissue types for a variety of different applications. They provide us with a window into human biology. They provide us with human models of human disease. We can use those human cell and tissue models as a platform for drug discovery and therapeutic development. And because this is a genetically tractable system, we can go in and genetically modify the stem cells, and this allows us to study inherited conditions. It also allows us to create gene-modified or gene-edited stem cells that can be used therapeutically. And the long-term holy grail of this field is the development of cellular therapies and tissue engineering approaches that might allow us to repair or regenerate damaged tissues and restore function to failing organs. So 10 years ago, Andrew Elefanty, Ed Stanley, Elizabeth Ung, and Dave Elliott brought pluripotent stem cells to MCRI. And over the subsequent decade, this research activity has grown to over 250 staff and students, working across a range of research areas from fundamental developmental biology through to disease modeling, drug development, and cellular therapies. And this research is powered by our discovery enablers, including embedded facilities that drive our research, such as the iPSC derivation and gene editing facility, our drug discovery facility, and a number of tissue biobanks that are a really critical resource for our research. And we're doing this in partnership with industry partners, again with clinicians across the Royal Children's Hospital, and also globally through the ReNU Consortium. So ReNU, what is ReNU? It's the Novo Nordisk Foundation Centre for Stem Cell Medicine, and it was launched last year through a generous gift from the Novo Nordisk Foundation. It's the brainchild of Professor Melissa Little, and it brings together 3 of the world's leading stem cell research institutes, the University of Copenhagen in Denmark, Leiden University Medical Centre in the Netherlands, and MCRI here in Melbourne to transform lives with stem cell medicine. And our vision is to create a new generation of innovative, safe, effective, and socially sustainable stem cell-based therapies for incurable conditions. And we're doing this through international collaborative network. So what has ReNU meant for MCRI? Well, it's meant a significant injection of funding. And to put that funding into perspective, it's roughly equivalent to the entire MRFF stem cell therapies mission coming into MCRI over the next decade. This has resulted in rapid growth of this activity at MCRI, but most importantly, it provides our researchers with access to world-class facilities and research collaborations across the globe. And it also provides our researchers with incentives and the capacity to engage in targeted research towards translational outcomes. It takes a long time, a lot of money, and a fair bit of luck to take an idea all the way from early stage discovery science to eventual clinical application. And what ReNU provides its researchers with is incentives and an opportunity to engage in those early stages of de-risking of the science and that important therapeutic proof of concept studies that allow us to move the needle, that allow us to push that early stage discovery science a little further along this pipeline towards clinical application. And we realize that we're going to need partnerships and further investment to then take that research further through the clinical development phase. So today you're going to hear from 2 of our flagship research areas in heart and kidney. This is James. James was born with one of the most severe forms of congenital heart disease, known as hyperplastic left heart syndrome. Essentially, he was born with half a heart. Children like James, who were born in the 1970s, for example, conditions like these were pretty much a death sentence. However, due to surgical and medical advances over the last several decades, that's no longer the case. And indeed, many children like James are now living well into adulthood. And for the first time in history, there are actually more adults living with congenital heart disease than there are children. However, these individuals are living with the consequences of their congenital heart disease throughout their lifetime, and this places them at increased risk of a number of complications, including heart failure. So today you're going to hear about some of our stem cell research that's really trying to unravel some of the mechanisms that drive childhood heart disease, how we're using these as platforms for therapeutic development, and some of the early stage research where we're using tissue engineering approaches to develop regenerative medicine strategies for some of these conditions. You're also going to hear from our kidney team, and they're using stem cells and genomics to try and develop new treatments for children like Charlotte. Charlotte was born with congenital nephrotic syndrome. Thankfully, medical management of her condition delayed kidney failure for long enough such that she was eventually able to receive a kidney transplant. But what if children like Charlotte could be spared from the need for kidney transplantation? What if we could actually prevent the progression to kidney failure? And you're going to hear today about some of the work that we're doing in that area. So I'd now like to invite three of our rising stars, Kevin Watt, Holly Voges, and Dennis Beenroth, who are going to talk to some of the work that we're doing in stem cell modelling of heart disease.